Welcome everyone. Today we have another new episode, and this episode is very much important in the present scenario. It's UAV, and this is one of the major industrial revolutions. The present state and future prospect of autonomous control technology for industrial drone. So I'm gonna discuss with one of the research paper. This research paper is very much important for the drone development. The roadmap for the industrial revolution is the sky. If you, I will discuss this research paper in an effective way. The roadmap for the application and technology development of unmanned aerial vehicles in Japan, which was set by the Japanese government, defined the flight level of small UAVs, drones, as shown in Figure 1. It classified the flight level into four stages, where level 1 is a radio control level, level 2 is a autonomous flies drone with visual line of sight, level 3 is an autonomous flight where beyond virus line of sight without any observance in an less populated area, and level 4 is an autonomous flight with BVLOS in a populated area. Level 3 is anticipated to be achieved in 2018, and level 4 is a 2020. So if you see these things figure, here this is the flight level of the small unmanned aerial vehicles drones. Popular area, less populated area. Level 1, visual lines of the sign flights, visual lines of the sign flights to be applied from the around 2020 and to be appointed from around 2018. So concept of guidelines, navigation and control as a ideal or autopilot. UAVs are used in an increased number of civilians applications such as inspection, exploration dangerous and complex environments such as disaster area, etc. Autonomous guidelines, navigations, and control are required to achieve these missions without direct or continuous human control. Guidance and navigation system were originally developed for rockets. The system gains more widespread use with the advent of spacecraft, guided missions, and UAVs. Figure 2 show a simple block diagram on GNG system in a UAV. GNC consists of the three essential parts. Number one, guiding system that sends the UAV forward a desired state. Number two, a navigation system that track the current locations of the UAV and estimated its state. Number three, a control loops. The concept of guidance commands and uses navigation's data to generate the actual actuators signals to follow the guidance objective as well as to stabilize the vanish attitudes. So in the sensor part, it has IMU, GPS, laser visions. Guidance system, it has navigation system, flight control, reference, transaction and control. In the octator parts, it has throttle, radar, elevators and eliers. In the guidance system, a guiding system can be defined as the driver of a vehicle of the to achieve some missions. While guaranteed safely, it takes input from the navigation system and uses targeting informations to send signals to the flight control system that will allow the vehicles to reach to destination within the operating constraints of the vehicles. Planning the UAV flight path or trajectory is the chief problem in autonomous UAV problem. The basic difficulties include particularly known and changing environment, extraneous factors such as threats and computational complexity, because the trajectory planning problem is generally solved using mathematical optimizations method that are computationally too demanding. Navigation system. What is navigation system? The navigation system in the broad sense, navigation is the art and determination where you can for autonomous vehicles such as robots and UAV. Navigations can be defined as the process of extracting information about the vehicle self motions and also the surrounding environment. This information can be metrics such as distance or tropical such as landmarks and or any other cues that are useful to achieve the task and to guarantee safety, for example using optic flow to avoid obstacles. Today's complex navigation system typically have multiple redundancies to address draft, improve accuracy, and address isolated system failures. So autonomous class of drone and future roadmap. The degree of autonomous of the drone, which is level 3 and level 4, are achieved are given in the 3.6 figure 3 present the autonomous of drone, which is almost a synonyms of the safety classified into 5 stages from the stage A to class E, class A to class E. With the concept, the guidance level, the navigations, and the level of the control, the sensor of an assumptions of the logistics, all which are detained for each of the 5 stages. Class E is a level of a level at which the operational skill of human is put to the test in a radio control operating drone. Class D is the class in which an autonomous flight is made possible as a so-called waypoint flight, that is a program flight for everyone from takeoff to the landing is determined the trajectory plan made in advance by a human on as assumption that a GPS radio wave can be received. Most of the industry drone currently commercially available can be judged as Class D. Class C is for drone capable of the autonomous flights even under a non-GPS environment. It used various methods such as images processed using a camera, later leaders, total station, sound and radio waves, various drone abnormality notification and the link are similar to the those of class D. And the presence of mission continuous is judging by a human. So I just try to help to understand the different level. Level A, visual line of sight, night, and the presenting the correlations between the autonomous class and the flight levels, and the presenting what level of the autonomous evolution is capably the permitting what might level. Currently in operating visual line of sight, night, starting application from about 2018 beyond visual line of the sight over less populated area, and beyond the visual line of the sight flight over populated area. These are the major area where we can focus. Autonomous control technology required in autonomous class B of drone. Fault of multi rotors helicopter during autonomous flight can be roughly divided into four. The first is community system fault related to uplink and downlinks between the ground and the drone. The second is the sensor system fault related to navigations such as IMU sensors and the broad meters, GPS river, INS related faults and the vision. The third is control system fault, mainly in the microcomputer board that carries out or control calculations peripheral devices, and the fourth of multicopter propulsion system fault, mainly in the driving system. This fault can be held in general by using a redundant system. So these are the some interesting things that adjustment mechanism, block diagrams, planning meter estimated, planned, control, design signal or outputs. Drone behave when it's dropped to of water. Ideal state of drone autonomy in near futures. As described in figure 2 and 3, the GNC play an important role in order to carry out of autonomous flights while quickly recognize as obstacles in front of the drone along the flight. Autonomous carry out crash avoidance, recognize a complicated environment, and self-generating the flight route. This is also a GPS, GNS, FB, and different kind of models for these things. So the drone of the class A, which as next generation industry use drone and might be called real flight robots, are required to have reliability, durability, and safety that allow them to repeat a daily flight of the 8H for about 5 years. It is needless to mention an obvious procedure of daily regular inspections and component replacements. This is the writer biography who is actually doing necessary research on that particular points. So beside that, like these drone technologies and other things, if we want to understand these things in an effective way, now many of the drones and this kind of things uh, actually happening right now, and we have a lot of interesting methods uh, and many more interesting things which is moving right now. So we have to understand that what is actually uh, uh, what is actually very much important for our mechanism, and what is actually playing an important role for our economy. So in the fourth industrial revolutions, actually this kind of things happens, and in the fourth industrial revolutions, we can move with a different kind of moral things. But I just try to share some of the important aspects of the drone technology, which is actually adding some sort of uh, important aspects. Here is a drone cars. Driverless cars versus drone. By land or by air, which technology will be most disruptive? Smith School's Professor Hang Luk and the Oliver Shackles, along with Matt Scenario from the University of Maryland, they are actually showing these points. So self-driven car, it will be 2D environment, established regulations, more cox states, more perspectives, and a drone 3D environment, shifted regulations, less congested, less 10 feet of delivering presented a challenge. Look, these things. So it has a commercial flights, which no pilot. Drone delivery, drone carried on demand medical to a remote island in the North Sea. Drone inspected the blade of massive wind turbine, and the moral dimension. If a child ran in front of the self-driven car, will it react differently than if obstacle were an adult or perhaps an animal? In the scenario, which is the car must choose between the safety of its passenger or the perspective of another life. So in that particular situation and the case study, potential market disruptors, like for the self-driven car, more people will skip car ownerships and creating hosts for autonomous. Safer road will reduce the needs for a car insurance, autonomous shops, and twin campaigns. Cities will lose revenue from the traffic and parking citations. Drone. Could delivery companies such as UPS and FedEx face disruptions as Amazon moves toward drone delivery? Technology will make airline pilot, helicopter pilot, and other obstacle. Potential market disruptions, self-driving cars. More people will skip car ownerships, creating homes for automakers. Safer road will reduce the need for a car instance, autonomous shop and twin companies. Cities will lose revenue from traffic and the parking citations. Drone ground delivery companies such as UPS and FedEx face disruption as Amazon move toward drone delivery. Technology will make airline pilots, helicopter pilots, and other obstacles. Self-driven cars will have more immediate impact of the people life, just from the time they gain during the communicate. So this is some of the moral dimensions, and for the drone, farmer can control her driverless tractor from a remote control system, and drone overhead has sensor that measures soil conditions. Passenger write a report during his morning communicates, and the self-driven car does not need collisions in insurance. Instead, it has an insurance against cyber security breakers. So these are the some of the strategic things of the like drones, potential drones, and self-driving cars. And if we can understand these things, and if we can make a proper ecosystem, then we can create a very good impact. So thank you everyone for joining today's sessions. If you have any question, you can ask me.